So in this video, I'll go through the reaction questions from exercise 1 in 25.4, which is when we've looked at directing groups. So the first one is straightforward. It's just a benzene ring. You react it with nitric acid in the presence of sulfuric acid, and you add an NO2 group. Because there's no substituent on the benzene ring, you can put the NO2 group anywhere you like. Next one, I'm just adding a chlorine. Again, I can put that anywhere I want. But in C, because there's already a chlorine there, I do need to think about where I put the next chlorine. So chlorine is a 2,4 director, meaning the new chlorine I'm going to add to the ring will either go to position 2, which is either side of my original chlorine, or to position 4, which is directly across. So you can get two products, either with a 1,2 relationship, or you've got the chlorines in a 1,4 relationship. In the next one, my original substituent is this acyl chloride group, and this group is a 3 director. So you need to know the different groups and you need to know where they direct to. So I redraw my benzene with my acyl chloride group. I know it's going to send the new substituent to carbon 3, and that new substituent is going to be a chlorine. So 1, 2, 3, that chlorine is going to go there. The next one, my original substituent is an OH group. This is a 2,4 director. So when I add on my new substituent, it's going to be either position 2 or position 4. So I draw out my OH. The new substituent, remember the benzene is going to attack this carbon here, which is bonded to another carbon, as well as being doubly bonded to an oxygen. The chlorine I'm not going to include, so I can put that on position 2, and either side is absolutely fine as position 2, or I can have it on position 4, so it will be down here at the bottom opposite the OH. The next one, COOH. This is a 3 director. So when I'm doing this, I'm putting this on carbon number 3. Just pay attention to what you're actually adding. You're not adding a bromine. Okay, remember when we wanted to add bromine, we just had Br2 and our halogen carrier catalyst. Now I've got an alkyl halide, I've got an alkyl bromide, and this is Friedel-Crafts alkylation, and it's the alkyl group that I'm going to be attacking. So this carbon here, that's my electrophile, that's going to get attacked, and in the process I'm going to end up losing the bromine completely. So I'm not adding a bromine. Instead I'm adding 1, 2, 3 carbons to position number 3, so 1, 2, 3. The last one, I've got a methyl group there originally. Methyl groups are 2,4 directors, all alkyl groups are, and I'm not reacting with HNO3, which means I'm going to be adding a nitro group. So I've got my methyl group there, I can add my NO2 there, or I can add my NO2 group opposite my methyl group. So I've got two different possibilities. So remember, when you're doing these, you're looking at the substituent that is already there. That's the one that determines where the new substituent goes. I'm also going to do question 20 for you. That's when I give you benzene and I ask you to complete a 2-step synthesis. And this is important. The order of these steps are important so that you get the right relationship. So first of all, I'm starting with benzene. I'm just going to zoom in on this a little bit. So I'm starting with benzene, and I want to make 3 nitromethyl benzene. So I'm just going to draw what I'm starting with, benzene, and draw what I'm going to try and end up with, which is 3 nitromethyl benzene. So I've got a methyl group, and then which counts as carbon number 1, and then on carbon number 1, 2, 3, I've got a nitro group, which is an NO2. So I need to add a methyl group and I need to add an NO2 group. So there are going to be 2 separate reactions. You're told this is 2-step synthesis, but I need to figure out which order I'm going to do this in to get the right relationship. So we can see here that we've got a 1-3 relationship between the 2 substituents. My alkyl group is a 2,4 director. It always gives either a 1,2 or a 1,4 relationship. My NO2 group is a 3 director, meaning it always gives a 1,3 relationship. In this question, I want my product to have a 1,3 relationship, which means I'm going to add the nitro group first. So I'm going to take my benzene ring, I need to know how to nitrate, so I need to know those conditions. So I'm going to be using HNO3, and that's going to be concentrated nitric acid. And I'm going to need concentrated H2SO4. I'm going to carry this reaction out at 50 degrees. And when I do that, I'm going to be adding my NO2 group to my benzene ring. Once my NO2 group is in place, as I've already said, it is a 3-director. So any other substituent that you add is going to add to the 3 position. So now I'm taking my nitrobenzene and I need to add an alkyl group. So again, you need to know the conditions for it. If I want to add an alkyl group, I'm not just going to be reacting it with methane. Okay, methane's unreactive. It's not an electrophile. So what I need to do is I need to make that carbon electrophilic. So instead of having carbon bonded to 4 hydrogens, I'm going to have carbon bonded to 3 hydrogens and a halogen, because that halogen is more electronegative. It will make my carbon delta positive, and I need my carbon to be an electrophile if my benzene ring is going to go and attack it. Remember, your ring is your nucleophile. You need an electrophile, and I can make it an electrophile by adding a halogen. Just adding a halogen is not enough though. It's still a weak electrophile. I'm going to need to use a halogen carrier catalyst. This is Friedel-Crafts alkylation. Then my ring is going to be able to attack this carbon. I lose the chlorine and I form a new bond between the ring and the CH3. And when I do that, okay, because your NO2 is 3-directing, that CH3 group is going to go 1, 2, 3. Or I could even do it the other way, 1, 2, 3, and put it, here. And that would be exactly the same thing. In the next question, you're asked to form 2 nitromethyl-benzenes. I'm just going to rub this out so I've got space, and I'm going to go through the same process again. So you'll see now it's going to be a similar reaction because I'm adding the same substituents, but my relationship is different. So I've now got 2 nitromethyl-benzene, which means if I were to draw out my benzene with my methyl group, the NO2 group is on carbon number 2. So there's now a 1-2 relationship. And then again, if I look at my substituents, I know methyl gives me a 1-2 or a 1-4 relationship, and nitro group gives me a 1-3 relationship. And in this case, I want that 1-2 relationship. So this time round, I'm going to put the methyl group first. And the actual reaction is going to be exactly the same as what we've seen before. You're going to be using all the same reagents. I'm just going to use, actually no, I'll use chlorine. Use any of the halogens though, it's fine. And you're going to add your methyl group, and I'm going to use my aluminium chloride. Just make sure your halogen carrier catalyst, that the halogen in your catalyst matches the halogen in your reagent. And then I take my methyl benzene and I react it with my concentrated nitric acid, my concentrated sulfuric acid, and that adds a nitro group. And because my methyl group is my original substituent, it directs to the 2 position. It also directs to the 4 position, so you get more than one product, but here you're just asked for 2 nitromethylbenzene, so that's the only one I need to show. So yeah, with these questions, there's quite a lot in it. You need to know your reagents and your conditions in order to be able to put the substituents onto the ring, but you also need to pay attention to the order you carry out those steps to make sure you end up with the right relationship between the substituents.